Okay, let's look at some concept level questions. So LCM of these two polynomials. So LCM is the same way. What we do is basically look at least common multiple, and the way we do for numbers, again, just trying to refresh your memory. Say for example, I have got 24 and 16, two numbers. What I'll do, I'll try to factorize it. So I'll get 2 into, basically, how do we factorize? Here I'll write, start with the smallest prime number, and then I again try to divide, and until I get to a point wherein I cannot divide it further. The number of irreducible factors which we have here is 2 into 2 into 3. And here, what we have here is that 16. 16 is nothing but 2 into 2 into 2 into 2. Now we have got 4 here, 2. So what we do here when we are looking at LCM, we look at the different factors, basically unique factors here. So unique factors are 2 and 3. So I've got 2 and 3. And then we look at the highest power of each of these factors, and then raise it to that power. So here 2 is like 4 times, 2 to the power 4 is there. Here it is more like 2 to the power 3 into 3. Here it is like 2 to the power 4 into 1. You can say that. So I'll raise 2 to the highest power of it, so which will be 4. 3's highest power is 1, so this will be 1. So my LCM here will be 2 to the power 4 into 3, which will be 48. And as I was saying, that what is least common multiple is basically you look at 16 and then write multiples of 16, 16, 32 and 48 and so on and so forth. And you will write 24's multiple 24, 48 and then 72 and so on and so forth. So the least common multiple of both of them is 48, and that's the reason your least common multiple for this is 48. Okay, the same principle I'll be applying even in okay, this is LCM. And what about HCF? When I'm looking at HCF, HCF would be the common factor here. So HCF here, the common factor is 2 is the common factor, and 2 to the power 3 is the highest common factor. Highest common factor is 2 to the power 3. So HCF of these two numbers would be 8. And the same principle we will follow even in case of polynomials. So what we'll do, first we'll try to factorize it and then get to a level wherein it cannot be factorized further. And then once we have done that, then we'll look at how to evaluate the LCM. So LCM of these two polynomials, 18. I've got 18 x to the power 4 minus x cube plus x square. And then I have got another one which is 24 x to the power 6 plus x cube. Now I have to basically factorize these two. And the factorization you've learned in standard 8 itself, but it's still we will do now. So here I'll factorize. So 18 as well need to be factorized. So 2 into 9 and then 3. So basically this is 2 into 3 square, wherein this is x to the power 4 minus x cube plus x square. I can take x square common. So here I will be having x to the power 2 minus x plus 1. And here when I write 24, again I try to factorize to 24. I get 12, I get 6, I get 2 into 3. So this will be 2 to the power 3 into 3. And then from here I can take x cube common. Then this will become x cube plus 1. Alright. Also, I know that x cube plus 1, I can write x cube plus 1 as 2 to the power 3 into 3 into x cube. And x cube plus 1 I can write as x plus 1 into x square minus x plus 1. Why? Because a cube plus b cube is equal to what? A plus b into a square minus ab plus b square. And here is x cube, and then x cube plus 1 can be treated as x cube plus 1 cube, and that can be treated as x plus 1 into x square minus x into 1 plus 1 square, which is nothing but this one. Now you have to tell me, I factorize it to the extent which is possible here. Now I have to look at LCM. Now I have to write first the distinct ones. So this, there is 2 here, I'll write 2. Then there is 3, then in terms of number I'm done. Then I'm looking at x. Okay, x is 1. Then I have got x plus 1, and then I've got x square minus x plus 1. Now I have to start writing the highest power of each of these. So 2's highest power is 3, so I'll write 2 to the power 3. 3's highest power is 2, so I'll write 3 square. X's highest power is x cube, so I'll write cube. X square minus x plus 1's highest power is 1, so it is 1. X plus 1's highest power is 1, so it is 1. So either you can leave it here or you can just multiply. 8 into 9 is 72. You can write x cube, and then this will x plus 1, this will become x cube plus 1 again. So either you can write this or this. Okay, so we check the common one, right?
Yes. Yeah.
So here 2 to the power 3 was common in both of them. So for HCF, what will be the common one from these two? HCF is the common. LCM is the highest power of the distinct factors.
Oh.
Second, 2 x cube plus x square plus x. This was your px or whatever. And this you got it as 3 square into x you took common, then this became x square plus x plus 1. Then you had got this one, which had 3 into x cube plus 1, which we wrote as 3 into x plus 1 into x square minus x plus 1. Now I have to get the LCM. Okay, if I have to get the LCM, this is maybe fx. So now what do I have to do? What do I have to do for LCM? I have to write all the distinct factors. So what are the distinct factors here? First of all, first let's write all the distinct factors. What are the distinct factors here? So I'm not talking about the common one. So this is the LCM, right? In LCM, we have to write all the factors which are there. Then write the highest. Again, what are the ones here? So if you look here, what are the distinct ones here? 3x and then x square minus x plus 1. Okay. What are the distinct factors here? 3x plus 1 and x square minus x plus 1. Okay. Now, I'm looking at both of them together. So the distinct factors are 3x, then x square minus x plus 1. So I'm done with this, and there is 3. Okay. 3 is already taken care of. Then x plus 1, okay, it was not taken care of, so I'll write x plus 1. Then this is not taken care of, x square minus x plus 1. Now I've written. Now I have to look at the highest power of each of them. So 3's highest power is 2, so I'll write 2. X's highest power is 1, so this is fine. X square minus x plus 1, highest power is 1, is fine. X plus 1's highest power is 1, fine. This is fine. So now I've got 9 into x plus 1 into x square minus x plus 1 into x square plus x plus 1. This is minus, this is not minus, this is plus. This is plus. This is plus. So now you can see one of these will be probably this is the one. Second option is the one. Okay. Why LCM is so important is, as I mentioned, because to fact do the sum of two rational functions, right? We had to take the LCM, and it's something which you have to keep doing. Then only it will come to you. Okay, so let's do the next chapter, which is called